Okay, so let's talk about solving a quadratic by factoring. First of all, the thing that you want to think about when I'm solving a quadratic by factoring, what I'm really doing is thinking about the graph of a quadratic, which might look something like this. It's a parabola, so it could be something like this, or it could be something like this, or maybe something like this. So we're touched right there on the x-axis, or maybe it doesn't touch the x-axis at all. Okay, so every time I hit the x-axis, what happens is I get an x-intercept, or a root, or a solution. Okay, and that's what I'm going to be doing. Hold on, lovely bells. That's what we're going to be doing when we solve a quadratic. So I'm trying to find where does this parabola hit the x-axis. Sometimes it hits in two locations. So I have two solutions here. Here I have two solutions. Here I have one solution. And here I have no solutions. Okay, so any of those are really possible. Now, if we're talking specifically about solving by factoring, we're going to be looking at two solutions or one solution. This no solution shouldn't occur because otherwise it wouldn't factor. All right, so now let's look at it. How do we solve a quadratic by factoring? So when I look at this problem right here, I have something times something equals 0. Well, for that to be true, something times something equals 0, one of these parentheses, either A or B, has to equal 0. So what I'm going to do is set each of these factors, x plus 3 and x minus 9, equal to 0. So I set x plus 3 equal to 0. And I set x minus 9 equal to 0. So to solve this, I just subtract 3, and x equals negative 3 is one of my solutions, and x equals 9 is my solution. Okay, notice again, this is an equation. There's an equal sign here. So I'm getting what x equals. Unlike if this just had a factoring problem, which I'll compare in a second. Okay, so here I solve my two equations. I got my two solutions. Remember, it could have two solutions, one solution, or no real solutions. So let's look at another one. Here's my quadratic. It's not factored for me, so I have to factor it to be able to split it up into my two parentheses. So first thing I always look for is a greatest common factor. Actually, let me back up a step. First thing I have to do is make sure that the quadratic equals 0. Unlike before, we were just factoring a problem like this. There was no equal sign. This equal sign wasn't here before, and we just had x squared plus 8x plus 16, and we factored it. We're still going to do that, but we're going to take it a step further. So first of all, I need to make sure everything is on the same side and from highest power down to lowest power. So my x squared comes first, then my x term, then my one without an x. So I have it equals 0. Check step 1 off. Now, can it be factored? First thing we look for is greatest common factor. Is there anything that goes into all three of those terms? No, there's not. So then we start on our guess and check. First term times first term gets first term, so I have x times x. Sorry, my x is messed up there. And then I'm multiplying to get 16, which is 1 and 16. That's 2 and 8, or 4 and 4. So I try a couple different things till I get what I want. Sorry, my pen is being not very pleasant. So it looks like I'm going to get 4 and 4 as my two solutions. And again, you use guess and check until you find the one that works for you. Okay, so I make sure this is working. Now I have an equal 0 here. So this is x squared plus 4x plus 4x plus 16. So that's x squared plus 8x plus 16. That's good. That's what we wanted. So it does work. Now I'm going to take those two factors and I am going to set those two factors equal to 0. So x plus 4 equals 0. X plus 4 equals 0. And now I'm going to solve that. So subtract 4 and I get negative 4 and negative 4. So here I just really have one solution because I got two of the same. All right, let's look at another one. First of all, is my quadratic equal to 0? Well, it's not. So I need to subtract 3 so that I can get a 0 on the other side. So 2x squared plus x minus 3 equals 0. Now, greatest common factor, is there one? No, there's not. So now I'm going to go to my two parentheses and do guess and check. I've got 2x and x. Those are my only things that multiply to get 2x squared. The only things that multiply to get 3 are 1 and 3. So you do guess and check until you find the one that works. In this case, this is going to be a plus and a minus because I'm multiplying to get a negative 3. So 2x squared plus 3x minus 2x, so that adds up to be my 1x, and then minus 3. Now, a lot of people say, don't I just take the opposite of the number over here to get what x equals? That is not true. When I set 2x plus 3 equal to 0 and x minus 1 equal to 0, my answer is not just negative 3. I have 2x equals negative 3. So my solution is negative 3 halves. Over here, I just have to add 1, and my other solution is x equals 1. So I have two solutions there. All right, last one. Is it equal to 0? No, my quadratic's not equal to 0. So I need to combine my like terms and get it all on one side. So I'm subtracting 2x squared, and I'm subtracting 8. So I have 2x squared plus 10x plus 12 equals 0. Now I'm ready to factor. Can it be factored? Let's see. Is there a greatest common factor? Why, there is. So I'm going to factor out the 2. Oops, that's not 6. Okay, so I'm going to put a 5 here. Plus 6 equals 0. Now I have to see, does this factor again? It does. Not greatest common factor again, but I have x, x. I need to see what multiplies to get 6. So 1 and 6 are 2 and 3. So choose one, see if it works. Again, multiply it out to see if it comes back to this, and it does. Now, when I'm setting this equal to 0, if you set 2 equal to 0, does that make any sense? I know it doesn't. 2 can't equal 0. 2 is a number. It's not 0. So they're not equal. So this doesn't make any sense at all. You could have just divided everything by 2 because it is an equation at the beginning. So I get x equals negative 2 as one solution and x equals negative 3 as my other solution. Okay, so that's the difference between solving by factoring and just factoring. When I factor, I just stop right here, and that's my factored form. When I solve by factoring, I have an equal sign, and I'm finding what x equals and getting my solutions instead of just factoring.